Question number 66 we have 2.408 into 10 raised to the power 21 molecules of urea are present in 200 ml of aqueous solution. It means the volume of aqueous solution is given 200 ml. Okay, the molecules of urea are also given. It means 2.408 into 10 raised to the power 21 molecules of urea. This is given in the question. They are asking you to find out the molarity. What you need for the calculation of molarity? Moles of urea, because urea is the solute, upon the total volume of the solution, and that should be in liter. Okay, so volume you have 200 ml, so it means 200 by 1000 you can do. This is the volume in liter. Done. Simple form, you can simply write it as 0.2 liter. Done. Volume you have. Now, but you don't have the number of moles of urea. You can find out using the number of molecules. So, I hope you know this formula, N by Na. So, number of moles is equals to number of particles given upon Avogadro number. So, N value, the number of particles I am keeping here, 2.408 into 10 raised to the power 21 divided by Avogadro number, I hope you know, 6.022 into 10 raised to the power 23. Everybody knows the Avogadro number. Okay. Now, if you just solve this, this is a simple calculation. So, 6 approximately 4 times it is. So, 0.4 you will be getting, and it is 0.4 into 10 raised to the power minus 2. Simplification I can do here, 4 into 10 raised to the power minus 3. I can write this way. Okay. So, molarity would be, these are the moles that we calculated. It is 4 into 10 raised to the power minus 3. Divide it by the volume. That volume is 0.2 liter. Volume should be in liter for the calculation of molarity. So, this will be giving me the value which is 0.02 molar. Done. And yes, it's correctly given here in option number 3. So, that would be my correct answer. Okay. Now, the turn is for the next question, number 67. 21 gram of nitrogen is reacted with 4 gram of hydrogen. Okay. The mass of the ammonia produced. So, Haber process it is for the formation of ammonia. Nitrogen is combining with hydrogen, giving you ammonia, though the equilibrium is maintained in this reaction. Okay. But I am writing this way. So, nitrogen combining with hydrogen forming ammonia. By just looking at this, you can simply say if it was 1 mole of nitrogen, then 3 mole of hydrogen needed and 2 mole of ammonia are formed. Done? Okay, let me proceed with the given values. You have 21 gram of nitrogen given. Okay. Here 4 gram of hydrogen is given. So, first of all, you need to find out the limiting reagent, because the amount of the product formed is dependent on the amount of limiting reagent. Okay. So, 21 gram of nitrogen is combining with 4 gram. So, I am just going to check with respect to the stoichiometry of this reaction with respect to the given reaction basically. So, N2 1 mole, it means how many gram it is? Yes. So, we know 1 mole means 28 gram of nitrogen combines with 3 to the 6 gram of hydrogen. Then it forms ammonia. Okay. So, you don't have 28 gram of nitrogen, you have only 21 gram of nitrogen, right? So, how much hydrogen is needed for it? Yes. 6 by 28 into 21. So, this would be 9 by 2. This is 4.5 gram. 4.5 gram of hydrogen is needed, right? This is the needed amount of hydrogen. This is required. What about the available amount of hydrogen? Yes, this is only 4 grams. So, if required amount is more and available amount is less, it means hydrogen is the limiting reagent. Getting it? And if hydrogen is the limiting reagent, then amount of ammonia formed would be dependent on the amount of the limiting reagent, it means the amount of hydrogen. Okay. So I am just once again just looking at this expression, 3 mole of hydrogen is forming 2 mole of ammonia. Getting it? As per the question I am proceeding, right? So I am taking the next page. 3 mole of hydrogen produces 2 mole of ammonia. It means 6 gram of hydrogen is forming 17 into 2. 34 can I write directly? 34 gram of ammonia. So how much amount of hydrogen we have in the question? So if you just look at the question, you have only 4 gram of hydrogen. So if 4 gram of hydrogen I have, then ammonia produced would be 34 by 6 into 4, right? So this comes out to be nearly, okay. So approximately I can mark here 22.6 gram of ammonia. This is my answer, okay. So this 22.6 gram nearly is given here in option number 1. Final answer? Okay. Now the turn comes for question number 68. Assertion and reason type of statement these are, and in this type of question you have to just read both the statements carefully, and then you need to identify whether reason is correctly explaining assertion or not. Okay. So assertion says, according to Heisenberg uncertainty principle, it is impossible to determine simultaneously the exact position and the exact momentum of an electron. Yes, this is the statement of Heisenberg uncertainty principle. This is right. Now, reason. The effect of Heisenberg uncertainty principle is significant both for the motion of microscopic objects, okay, and the macroscopic objects. Is it possible? No, it's not applicable for the macroscopic. Macroscopic particles are not following. Basically, this Heisenberg uncertainty principle is the very important postulate for the quantum mechanics, which is actually applicable for the microscopic particles, not for the macroscopic one. So here, the correct answer for this question would be A is correct, but R is not correct. Reason is not correct, right? So this way, my correct answer should be the option 1, okay? Now, I'm taking next question, which says total energy and the kinetic energy of electron present in second orbit of helium ion respectively are. So total energy of an electron, energy which is total, that is giving me the value minus 13.6 Z square by N square, and this value is in eV, electron volt, okay. So if you know the total energy, you can easily find out the kinetic energy as well. How? Because the kinetic energy of the electron is equal to minus E total. Clear? Now just find out the E total here. Formula you have minus 13.6 into Z square. So in this question they are asking about the second orbit of helium ion. So for the helium, the Z value is 2 and second orbit of its we are taking. So N value is also 2, N square. This will cut this way. So this total energy comes out to be minus 13.6 eV. Clear? Now if you want to find out the kinetic energy, Ke would be minus E total. So E total is minus 13.6. It will be plus 13.6 eV. So this answer is given. I have to just check the correct option. Yes, this is correctly given here in option number 3. That would be the correct answer for this question, and I hope you have chosen this. Okay. Now, question number 70 I am taking. Which among the following metals has the lowest value of the work function? So, work function is basically the minimum amount of energy needed to remove an electron during photoelectric effect, right? So, work function is actually based on the fact that how much electropositive metal is. More the electropositivity of the metal, easier to remove an electron from it, right? So in that case, if you just look at magnesium we have, lithium we have, copper and the potassium. Potassium is the alkali metal and if you just check in the alkali metal, the first group, you will find it is at the lower position, right? So the order of the electropositivity, if you want, I can just tell you: copper, less electropositive as compared to magnesium. Then turn comes for another alkali metal, which is lithium, and then potassium, right? So highest for this. And if it is highest for this, you can easily choose the right answer as the option 4.